Yes, sir. You can continue, sir.
Good evening, all. Good evening. Students, can you hear me?
Good evening, sir.
Good evening, sir.
Yes, yes. All right.
Good evening, sir.
Yes, Ajay. So yesterday we were learning about the ways of expressing concentrations of a solution in the laboratory. 10 methods, 10 different ways we learned. So weight by weight, volume percentage, weight volume percentage, parts per million, mole fraction, molarity, all that, So we'll work few problems based on that. I'm just showing the slide so that you will again go through and recollect what you learned yesterday. And then we can start off with few problems and continue with the next part of the topic, right? So you can just go through these formulas. Many more we'll have to learn as we go through this. So the first question is calculate the mass of aspirin. They've given you the molecular formula of aspirin as C9H8O4. Aspirin is a common name for acetyl salicylic acid. Acetyl salicylic acid. It's a common name. So C9H8O4 in acetonitrile. Acetonitrile. Methyl cyanide is commonly called as acetonitrile. Cyanides are called as nitriles. CN is cyanide, functional group, that's called as nitrile. So acetonitrile here is a solvent. When 6.5 grams of aspirin is dissolved in 450 grams of acetonitrile. They're asking you to calculate the mass percentage of aspirin in acetonitrile when 6.5 grams of acetonitrile is dissolved in 450 grams of 450 grams of methyl cyanide or acetocyanide, nitrile. What is given? They've given mass of aspirin. Mass of aspirin they've given to be 6.5 grams. Similarly, they've given mass of acetonitrile, CH3Cl. They've given 450 grams. 450 grams. They're asking you to calculate the mass percentage. How do you calculate the mass percentage? Mass percentage. Mass percentage is otherwise called as weight by weight percentage. So it is nothing but weight of the solute divided by weight of the solution into 100. This will give you mass percentage. This formula we are learning. We have learned also. In the yesterday's class we have learned. Now what is the mass of the solute? Aspirin is the solute. It is 6.5. What is the mass of the solvent here? What's the mass of the solution? So solution is nothing but solute plus solvent. So it will be 6.5 plus 450. That will be equal to 6 divided by 456.5. So on simplification, into 100, you have to multiply it by 100. Sorry, I missed out here. Percentage they're asking into 100. If you multiply it by 100, the answer what you will get is 1.424%. So the mass percent of aspirin in acetonitrile is 1.424%. Therefore, the answer for this question is option 1. Did you understand this question? Solving? Did you follow this? Students?
Yes, sir.
It's a simple problem, but you need to know the basics to work out these kind of problems. And interesting, this chapter, the numericals are very interesting. We can get to any level of numericals we can work in this chapter. The second question, a solution is obtained by mixing 300 grams of 25% and 400 grams of 40% solution by mass. Calculate the mass percentage of the resulting solution. Calculate the mass percentage of the resulting solution. What is given? What is given? 300 grams of 25% solution containing solute. Why do I say a solute? Tell me. The lesser quantity is this 300. And here it's 400 grams of 40%. Therefore, it will be what? A solvent. So second, what they've given is, they've given, 300 grams of 25% containing solute. What does it mean? In 100%, the solute is 25%. In 100 grams, the solute is 25 grams. So if that is the case, in 300 grams, what is the mass? So it will be 300 into 25 divided by, excuse me, 100. That will be equal to 75 grams. So mass of solute is 75 grams. Similarly, tell me what will be the mass of solvent. Mass of solvent, they've given 400 grams of 40% solvent. So therefore, what will be that? So therefore, 100 grams will contain what? 100 into 40 divided by, 40 divided by, am I correct? No, this is wrong. 100 grams contains 40%. So 400 into 40 divided by 100. So you will get it as 160 grams. 160 grams. Now they're asking you to calculate the mass percentage of the resulting solution. Now, in order to calculate the mass percentage of the resulting solution, I made a mistake again. This is not a solvent. This is also a solute. A solution containing, obtained by mixing 300 grams of 25% and 400 grams of 40% solution by mass. So both are solute. So total mass will be what now? Total mass of the solute. Total mass will be total mass of the solute. Total mass of the solute will be 75 plus 160. It will be 235 grams. So what will be the total mass of the solution? Total mass of the solution. Total mass of the solution. It will be 300 plus 400. That will be equal to 700 grams. Okay. Now, see, this is always a problem. You have to read 2-3 times the question. So they are taking two solutions. One solution is weighing 300 grams. In that, 25% of solute is there. The second solution is weighing 400 grams, and the percentage of solute is 40%. They are mixing both, and they are asking you to calculate the percentage of the resulting solution. That is why we are adding these two. So now tell me what will be the percentage of the final solution, mass percentage of solute in final solution. Mass percentage of solute. Tell me, how do I work? Mass percentage of solute. The formula we worked earlier, it will be 235 weight of solute divided by weight of solvent is how much? Solution is what? At 700 into 100. So that will be giving you 33.57%. That will give you 33.57%. This is the mass of solute, mass percentage of solute. Therefore, what will be the mass percentage of solvent or mass percentage of water? Water or solvent? What will be the mass percentage of water or solvent here? Totally, we take 100 as a percentage. 100 minus 33.57. That will be equal to 66.43%. 66.43%. Therefore, the answer for this question is option A. Just go through this problem again. If you have any clarification, you can ask me quickly. These kind of problems will be asked in the competitive exam. See, you have to answer this in a few minutes time, very small amount of time they'll be giving you. So you should be fast in working. So you can develop the speed only by practicing. If you do not practice, you will not get the speed. Then it will be difficult for you to answer all the questions. So kindly practice. Any clarification with this question? We'll go to the next one. Anybody? Please answer yes or no.
No.
No, you understood, right?
Yes, sir. Yes, sir.
Yeah. The next question is 34.2 grams of glucose is dissolved in 400 grams of water. Calculate the mass percentage. 34.2 grams of glucose is dissolved in 400 grams of water. Can anyone tell me what's the mass percentage of glucose? Quickly tell me. Ajay and anybody else, Dhanalakshmi, Ritika, whoever is there, tell me. Can I say weight of solute divided by weight of solution into 100? Can I do that? This is mass percentage. What's the weight of solute they've given? 34.2. What's the weight of solution? Now you tell me. What's the weight of solution? Please participate. If it's wrong, it's okay. Please participate. What's the weight of solution?
The 434.2.
434. That means it is 400 plus 34.2. So total solute plus solvent. So that will be equal to 34.2 divided by 434.2 into 100. We have to multiply this by 100. Percentage they're asking. Multiply by 100. So you will get the answer to be, all right, 43, not 43. You will get the answer to be 7.87%. So 7.87%. Therefore, the answer for this question is option A. Simple question. These three questions, what we learned is simple. We'll learn a few more questions based on this. The next question is 12.838 centimeter cube of benzene is dissolved in 16.8 centimeter cube of xylene. Calculate the percentage by volume of benzene. They're asking volume of benzene. What's the volume of benzene they've given? Volume of benzene is 12.83 centimeter cube. What's the volume of xylene? The volume of xylene is 16.8 centimeter cube. All right. Now they're asking what is the volume percentage? Calculate the volume percentage. That's what they're asking. Percentage by volume of benzene. So volume percentage will be what? You tell me. Volume percentage will be what? Volume of the solute divided by what? Volume of the solute divided by what? Volume of solution into 100. What's the volume of the solute? Volume of the solute is 12.8 centimeter cube. And volume of the solution is what now? 12.8 plus 16.4 into 100. So solute and solvent will give you solution. On simplification, you will get this as 43.24% by volume. So therefore, the answer for this question is option B. Is it clear? Is it clear? Everybody? Yes. Next question. Calculate the mass of urea required in making 2.5 kg of 2.5 molar aqueous solution. Molar. So we have to take solute and solvent in terms of kgs. So they're asking number of what is given. Now they have given moles of urea. Moles of urea they've given to be 0.25 moles. So why it's 0.25 moles, you tell me? They have given 0.25 molar. What do you mean by 0.25 molar? 0.25 moles in 1 kg of the solvent. This is 0.25 molar. This gives you the concentration 0.25 molar. We learned yesterday in detail. Now what we're supposed to find? They're asking you to calculate the mass of urea required to. So to find is mass of urea. Mass of urea. You should know what is the molecular formula of urea. What's the molecular formula of urea? The molecular formula of urea, anybody? CH2, not CH2, NH2CO, NH2. This is the molecular formula of urea. And the molecular mass of urea, you should remember, molecular weight of urea is 60. Remember this. Memorize this. Urea is an important molecule in chemistry. So therefore, the molecular weight of urea is this, and molecular formula is NH2CO, NH2. But they're asking you to calculate the mass of urea required to prepare 2.5 kg of 0.25 molar. So I clearly told you 0.25 molar solution means 0.25 mole in 1 kg of the solvent. 1 kg of the solvent. Now, when I say 1 kg of the solvent, it means how many grams? How many grams? 1000 grams. So 0.25 mole in 1000 grams. 1000 grams. Now, we have understood this. Therefore, we can write 0.25 moles of urea. What will be the weight of 0.25 moles of urea? Can anyone tell me what will be the 0.25 moles of urea weight? 1 mole is 60 grams. 0.25 moles means what? See,
0.25 by 60.
0.25 by 60.
60.
0.25 by 60 or 0.25 into 60? 0.25 mass mole of urea will be equal to 0.25 into 60. That will be equal to 15 grams. I will tell you why. All right, I will take some space here and write here. Now, 1 mole is 60. 1 mole of urea is 60 grams. Therefore, 0.25 mole of urea will be what? Cross multiplication. It will be 0.25 into 60 divided by 1. Therefore, it will be 15 grams. Did you understand this?
Yes, sir.
Yeah.
Sir.
Now tell me, 0.25 mole of urea is 15 grams. Therefore, what will be the weight of solution? What will be the weight of solution? What will be the weight of solution? One kg is how many grams?
1000 grams.
So that means the total weight will be how much? 1115 grams solution. Yes. This is the mass of solute, and this is the mass of solvent, water, and this is the mass of urea. So totally it will be 1015 grams. So therefore, this is for 1 kg. So 1015 grams, maybe we can write like this: 1015 grams of solution contains 15 grams urea. Now, if they say 2.5 kg, it is how many grams? 2.5 kg is how many grams? 2500 grams. So what will be the answer for this? It will be 2500 into 15 divided by 1015. On simplification, you will get 36.94 grams. What do you mean by this? What do you mean by this? If you take 36.94 grams and dissolve it in 2.5 kilograms of water, the concentration of the solution is 0.25 molar. 0.25. Well, did you follow this? How to work this problem? Just go through this quickly. Understood?
Yes, sir.
The next problem is, everybody others followed? The normality of 1.5 molar phosphoric acid is. The normality of 1.5 molar phosphoric acid is. Yesterday I was talking about normality, molarity. If you have to calculate normality, we need to consider equivalent mass. If we are talking about molarity, we need to consider what? The molecular mass I told you. Now just you observe this formula, phosphoric acid, H3PO4, and tell me what is the basicity of phosphoric acid. What is the basicity of phosphoric acid? Yesterday I spoke about acidity, basicity in detail. Tell me what is the basicity of phosphoric acid. What is the basicity of phosphoric acid? Quickly. Nobody want to try? Huh? It is 3 because we have 3 replaceable hydrogen. Therefore, the basicity of phosphoric acid is 3. So we know I didn't teach you this, but remember this formula. We know that normality is equal to a molarity into small letter n. Capital N is normality, capital M is molarity, small letter n is basicity. Small letter n is basicity. So normality will be equal to what? 1.5 into basicity is 3. Therefore, it will be 4.5. So 1.5 molar phosphoric acid is 4.5 normal phosphoric acid. Because normality we take equivalent mass and molarity we will take molecular mass. Therefore, there will be difference in the representation. So phosphoric acid, this formula you should remember. What's the relation between normality and molarity of an acid? Normality is equal to molarity into N. Normality is capital N, M is molarity, and smaller n is the basicity. All right. Similarly, if I ask you for 1.5 molar sulfuric acid, what is the normality of 1.5 molar sulfuric acid? What will be the answer? What will be the answer? Same formula. Tell me what will be the answer. What's the basicity of sulfuric acid? N is 2. So what will be the normality? Normality is M into 2. It will be 1.5 into 2. It is 3. It is simple. Yeah, it will be what? Simple. So you need to remember this formula. All right. So the next problem. How much volume of 10 molar HCl should be diluted with water to prepare 2 liters of 0.5 molar? 2 liters of 5 molar, sorry, 2 liters of 5 molar. How much volume of 10 molar HCl should be diluted with water in order to prepare 2 liters of 5 molar HCl? Tell me. Now, do you remember this formula anywhere using N1V1 is equal to N2V2? Have you used this? Or M1V1 is equal to M2V2? Have you used this formula any titration in the first year? Have you used this? Titrations, if you have done, to calculate the normality of the unknown, they will use this formula N1V1 is equal to N2V2. Yes or no? Normality of one solution into volume of one solution will be equal to normality into volume of the second solution. What does it mean? In the conical flask, if I take HCl, and in the burette, if I take NaOH, and if I say normality of HCl is N1, and volume we have taken as V1, then if I take the normality of NaOH as N2 and volume as V2, then at equivalence point, at neutralization point, at the color change from colorless to pale pink, what happens is N1V1 becomes equal to N2V2. Do you remember this titration? Have you done titration in school, college? Nobody? All right. Now, this formula is used in order to not only calculate the unknown solution, but this formula is also used to prepare dilute solutions. You know what is dilute solutions? A solution in which the concentration of the solute is less is called as a dilute solution. Now, see what they have given. They have given you 10 molar HCl, and they're asking you to calculate 5 molar HCl, volume of water required in order to prepare 5 molar HCl. This 10 molar is concentrated and 5 molar is what? Diluted. So we can write, so they've given molarity, no? So we'll write M1 only. M1V1 is equal to M2V2, not normality. We'll write M1V1 is equal to M2V2. M1V1 is equal to M2V2. Now we can write M1 highly concentrated, therefore 10 into V1. We don't know the volume, so we require the volume to be diluted water. M2 we know they want concentration to be 5 molar, and the volume they want us to be preparing in 2 liters. So what will be V1? 5 into 2 divided by 10, that will be equal to 1 liter. That will be equal to 1 liter. What do you understand by this? What do you understand by this? Anybody? What do you understand by this? All right. So if you take 10 molar HCl and if you dilute it with 1 liter, if you add 1 more liter of water, if you take 10 molar, 1 liter of HCl, if you add 1 more liter of water, the concentration reduces to 5 molar. That's what it means. So on addition of 1 liter to 10 molar, 1 liter of 10 molar HCl, the concentration of the solution will decrease to 5 molar. So is it okay with this problem? Any clarifications?
No, sir, no clarifications.
All right. The next part of the topic we will learn. I think we learned it yesterday. Solubility, we learned it yesterday. Anyways, we will learn continuation. To have the continuity, we will learn and we'll try to solve some problems also. Now, solubility, few more problems. Solubility of a substance is its maximum amount that can be dissolved in specified amount of solvent at a specified temperature. I told you clearly, maximum amount of solute that can be dissolved in 100 grams of solvent is called, at a specific temperature, called as solubility. So 100 grams of solvent you should take, you should add maximum solute possible, which dissolves, and that is called a solubility. Now, solubility of a solid in liquid. If every solid does not dissolve in a given liquid. We learned it yesterday. Sodium chloride and sugar is soluble in water, readily soluble in water, while naphthalene and anthracene is not soluble in water. We learned the factors also, like dissolves like. I told you, polar solutes dissolve in polar solvent. NaCl is a polar solute. Water is a polar solvent. Therefore, NaCl is soluble in water. Non-polar solute, anthracene and naphthalene and anthracene are non-polar solvent. They will be soluble in non-polar solvents like benzene, chloroform, carbon tetrachloride, alcohol, ethanol, all this. They will be soluble. They are called as non-polar solvents. These are called as what solvents? non-polar solvent. So polar molecules will be soluble in polar solvents. Non-polar molecules or non-polar solutes will be soluble in non-polar solvents, like dissolves like. Now, we have learned yesterday, this also we have learned, effect of temperature. If the dissolution is endothermic, what is endothermic? Endothermic means heat is absorbed, heat is supplied, heat is given to the system. Those kind of reactions are called as endothermic. Endothermic, normally delta H is positive. Normally delta H is positive. So if the dissolution is endothermic, what do you mean by that? In order to dissolve a solute, if it requires energy, it requires a heat, then those kind of reactions are called as endothermic reactions. For endothermic reactions, solubility will increase with rise in temperature. Since we need to supply energy, we need to supply heat. If you supply more heat, what happens? The solubility will be faster. That is what it means. Solubility increases with rise in temperature. Now, if the dissolution is exothermic, if heat is given out, I told you yesterday, if you remember, for endothermic, it can be any salt and any sugar. Salt and sugar, when you dissolve it in water, it absorbs energy from the atmosphere. Therefore, it becomes endothermic reactions. So on increasing the temperature, solubility increases. Next is exothermic. If the dissolution is exothermic, delta H is negative. So what happens? Solubility decreases with increasing temperature. Why solubility decreases? Already heat is given out. Already the heat is given out. Since heat is given out, some amount of solvent can evaporate. Some amount of solute can also get evaporated. Therefore, for a solute which is an exothermic, what happens is the solubility decreases with rise in temperature. Next is effect of pressure. We learned effect of pressure. Pressure does not have any significant effect. Pressure does not have any significant effect on solubility of the solids. In liquids, as they are highly compressible. So pressure do not have any significant effect on solubility of the solids in the liquid. So in case of solids and liquids, pressure do not interfere because solutes are highly compressible. All right. So this is what we learned yesterday. This is what yesterday. Why you have texted me? Someone has texted me, see you in YouTube, for whom I don't know. All right. The solubility of gas in liquid. This is important. Now the topic we are learning, solubility of gas in liquid. Now carbon dioxide gas, when dissolved in water, you get carbonic acid, H2CO3. This carbonic acid is nothing but soda water. Soda water. All the soft drinks, what we drink, is nothing but made of carbonic acid. All the soft drink contains what? Carbonic acid. All right. So carbon dioxide is a gas. Water is a liquid. Now we are talking solubility of gas in liquid. Solubility of gas in liquid. One of the example is carbon dioxide in water. Now, many gases dissolved in water, and solubility of gas in liquid is greatly affected by pressure and temperature. See, in case of solids, solubility does not affected by pressure. But here, in case of gas, solubility of gas and in liquid is greatly affected by pressure. Greatly affected by pressure and temperature. See, effect of pressure. The solubility of gas increases with increase in pressure. When you increase the pressure, the solubility of gas increases. Note this point. Okay, solubility of gas increases with increase in pressure. If there is less pressure, what happens is the gas will escape. Instead of dissolving, instead of getting soluble, it gets vaporized or it gets escaped. Therefore, when you pass high pressure, gas in high pressure, the solubility of a gas in water also, water or liquid, it will increase. So effect of pressure, the solubility of gas increases with increase in pressure. This is well explained by a law called as Henry's law. So the solubility of a gas in a liquid at constant temperature is directly proportional to the pressure of a gas. Is directly proportional to pressure of a gas above the surface of the liquid or solution. So Henry's law clearly says that solubility of a gas in a liquid at constant temperature is directly proportional to pressure of a gas above the surface of the liquid. Now, we learned pressure. On increasing the pressure, what happens? The solubility increases. See, the partial pressure of a gas in vapor phase is represented by letter P and is proportional to mole fraction. See, mole fraction is nothing but concentration. So that is what they say. Mole fraction is represented by letter X. So partial pressure of a gas in vapor phase is proportional to mole fraction. If you remove the proportionality sign, we give a proportionality constant, and that proportionality constant is called as Henry's constant. So this formula you should remember. Partial pressure is equal to Henry's constant into mole fraction. We learned mole fraction yesterday. How do you calculate the mole fraction of the solute? Anybody? Mole fraction of the solute? NB, number of moles of solute divided by number of moles of solvent plus number of moles of solute together. So number of moles of solute divided by total number of moles of solution will give you what mole fraction of the solute. Mole fraction of the solute is represented as X. Since we are talking about solute, we represent it as XB. All right. So applications of Henry's law. What are the applications of Henry's law? These applications-based question will be there in your regular exam as well as in the competitive exam. See, soft drinks and soda water bottle are sealed under high pressure to increase the solubility of carbon dioxide. If carbon dioxide is passed in low pressure, what will happen? Carbon dioxide will what? Escape. Therefore, in order to prepare soft drinks and soda water, carbon dioxide is passed into water. Therefore, what happens? The solubility of carbon dioxide increases. That's the first application. Next, this is also a very important application. The tanks used by scuba divers, deep sea divers, you would have seen in the National Geographic Channel or any other channel, people go deep into the sea. Those people will carry a cylinder on their back. Those divers are called as scuba divers. They are filled with air diluted with helium. They are filled with air and diluted with helium. Helium 11.7%, nitrogen 5.6%, and oxygen 32%. If it is not diluted with the helium, what happens? Air contains nitrogen also. That nitrogen will, when we breathe in, what happens is we get bends. We get bends in the body. When I say we get bends in the body, the texture will, change. Bend. The nervous system or anything will bend. When you come to the surface, what happens? And it will give extreme pain. And when you come to the surface, what happens? The nitrogen gas gets released. There's a possibility for health issues. That is why they mix helium with the atmospheric air. 11.7%. If you mix helium, nitrogen will not dissolve. Nitrogen will not be in a position to inhale. So for that purpose, in the tanks, scuba divers use 11.7% helium. The third application, mountaineers. People are climbing at a higher altitude. At a higher altitude, vapor pressure will be low. What do you mean by vapor pressure will be low? Oxygen will be less at higher altitude. At very high altitude, the percentage of oxygen will be low. So when percentage of oxygen is low, if the intake of oxygen is low, what happens is we will start to think, we will lose the thinking ability, clearly thinking ability. That sickness is called as anoxia. So therefore they fill liquid oxygen. Maybe they take liquid oxygen in the high altitudes. So mountaineers climb at high altitude, becomes patient of anoxia. They become weak and unable to think because of less percentage of oxygen. That is based on the vapor pressure. Because vapor pressure at higher altitude will be very less. When vapor pressure is less, it means concentration of oxygen is also less because vapor pressure is directly proportional to mole fraction. Now, in this case, in mountaineers' case, vapor pressure is directly proportional to the mole fraction of oxygen. So oxygen decreases there. Therefore, we lose to think clearly and we become weak. That process is called as anoxia. Next is temperature. What's the effect of temperature on Henry's law? Effect of temperature. As dissolution is an exothermic process, then according to Le-Chatelier's principle, the solubility decreases with increase in temperature. So solubility will decrease with increase in temperature. Assume that we are dissolving carbon dioxide gas and increasing the temperature. What happens? When we are increasing the temperature, already carbon dioxide is in what state? Gaseous state. When you increase the temperature, what happens? The escaping tendency of carbon dioxide will increase. Therefore, carbon dioxide will increase by decreasing what? The solubility. So temperature is inversely proportional to solubility. And pressure is directly proportional to solubility. Remember these two relations to work out some of the questions later. Is there any clarification with Henry's law so far? So Henry's law states there are two methods of defining Henry's law. Partial pressure of a gas in vapor phase is proportional to mole fraction of the gas in the solution. So if we remove the proportionality sign, we give a proportionality constant, and that's called as Henry's constant. Is it clear? Is it clear, students? Is it clear?
Yes, sir.
Yes, sir.
There's also participate. Not keeping well. All right. Now, the next one is some of the questions we will learn, and then we will see what can be done, possibly if we can continue or we'll see. Now, the next is, based on this Henry's law, we'll solve some of the questions. A few more questions I'll work sometime later. The law which indicates the relationship between solubility of a gas in liquid and pressure is directly proportional to mole fraction. Which law? Just now we learned. What is that law called as? Henry's law. That's called as what law? Henry's law. It's a direct question. All right. The second question. According to Henry's law, the partial pressure of a gas in vapor phase is proportional to mole fraction of a gas in the solution. For different gases, the correct statement about Henry's constant. For different gases, what's the correct statement about Henry's constant? Higher the value of KH at given pressure, higher is the solubility of gas. Higher the value of KH at given pressure, lower is the solubility of gas. KH is not a function of nature of gas. KH value for all gases is same at given pressure. So KH value for all gases is same. It's a constant. So therefore, the Henry's constant value for all gases is same at a given pressure. Hence, the answer for this question is option D. Answer for this question is option D. The third one, the value of Henry's law constant for some gases at 293 Kelvin is given below. Arrange the species in the increasing order of their solubility. Increasing order of their solubility from low to higher. See, they have given Henry's constant, helium 144 and hydrogen 69.16, nitrogen 76.48 and oxygen 34.86. They're asking the value of Henry's constant of some gases are given at 298 Kelvin. Arrange the gas in the increasing order. So it's helium less than nitrogen, less than hydrogen, oxygen. Okay, now remember, higher the value for Henry's constant, lesser will be the solubility. Lesser will be the solubility. So the answer for this question is option D. Helium is lesser than oxygen. Oxygen is lesser than nitrogen, and nitrogen is lesser than. See, helium is a noble gas. So oxygen is lesser than nitrogen, and nitrogen is lesser than hydrogen. So oxygen is soluble. So this is based on, it is not a direct relation. So you should remember this value. Oxygen is more soluble than the nitrogen and hydrogen. Next question, hydrogen sulfide. Hydrogen sulfide is a toxic gas used in qualitative analysis. You would have done salt analysis in your lab. Hydrogen sulfide will give a very bad smell, rotten egg smell. Its solubility of hydrogen sulfide in water at STP is 0.195 molal. 0.195 molal. What is the value of KH? What is the value of KH? What is the value of KH? The value of KH will be 69.16 bar. Bar is the pressure. So they're asking what is the value of KH. They've given 0.195 molar. Toxic gas is used in qualitative analysis. If the solubility of gas, hydrogen sulfide in water is 0.195, what is the value of KH? Just give me a second. I'll get back to you with this solution. Excuse me, where is that? 1 minute, you give me. The solubility. Give me a minute time. Somewhere I missed out this question working. Yeah. So H2S, what's the number of moles of H2S they've given? The number of moles of H2S they've given is 0.195 moles. Since it is in solution, so we need to calculate number of moles of water. Number of moles of water will be 1000 divided by 18, because 1 molar means 1 kg. 1 kg is 1000 grams. So divided by 18, it is 55.5 moles. 5.5 moles. Hence, the mole fraction. What is the mole fraction of H2S? Mole fraction of H2S is equal to 0.195 divided by 1.195 plus 55.5. So that will be equal to 0.0035. This is the mole fraction of H2S. Now, and bar, 1 atmospheric pressure. 1 atmosphere is atmospheric pressure. As per the Henry's law, Henry's law, we can write the pressure is what? Partial pressure is equal to KH into what? Mole fraction. So what will be KH? KH will be equal to pressure divided by mole fraction. Pressure we just now we found out it's 0.987 and mole fraction is 0.0035. And simplification you will get 69.16. Therefore, the answer for this question is option B. Is it clear with this? Is this clear? Yeah, students?
Yes, sir.
Yeah. The next problem, and we'll stop with this last problem, we'll stop and we'll see further what we can do. Where's the next problem? Yeah. How much of oxygen is dissolved in 100 ml of water? How much of oxygen is dissolved in 100 ml of water with the partial pressure of 0.5 atmosphere and KH is KH Henry's constant they've given. How much of oxygen? How much oxygen is dissolved at 290 Kelvin if the partial pressure is of oxygen is 1.5. What's it? 0.5 atmosphere and the KH value they're given 1.4. See, solubility is also given by the formula KH into partial pressure. Solubility is also given by KH into partial pressure. Now, they have given the partial pressure of oxygen to be 0.5 atmosphere. So therefore, what is the solubility? So KH they've given us 1.4 into 10 to the power minus 3 into 0.5, given partial pressure to be 0.5. Therefore, the solubility will be 0.7 into 10 to the power minus 3 molar. So solubility will be 0.7 into 10 to the power minus 3 molar. Now they're asking you the question, how much of oxygen is dissolved? In order to find out the oxygen dissolved, we should know that this is nothing but solubility. So we can say molarity. What is the formula to calculate molarity? 1 minute. Molarity, where is that? Molarity is given by the formula number of moles of solute divided by volume of the solution. Now solubility they have given. So solubility they have given to be, or we can write the solubility as 0.7 into 10 to the power minus 3 can be written as mass of oxygen divided by, what is the solubility now? Tell me, mole fraction now. So mass of oxygen plus volume of the solution. Volume of the solution. So that will be equal to 0.7 into 10 to the power minus 3. That will be equal to mass of oxygen divided, because we need to find how much of oxygen is dissolved, divided by 32 grams. Molecular weight of oxygen is 32. Into what is the volume of the solution? The volume of the solution is 100 ml, therefore it is 0.1 liter. So mass of oxygen will be what? 0.7 into 10 to the power minus 3 into 32. So on simplification, we will get it as 2.24 into 10 to the power minus 3 grams. That is equal to 2.24 milligrams. Hence, the answer for this question is 2.4 milligrams, option C. So take time to understand this problem. It's there on the screen. If you have any clarification, you can ask me. Otherwise, we'll continue with the next concepts and questions in the next video, next class. Any clarification so far? Huh? No clarification, Ajay, under this?
No, sir.
Okay. Ajay, you're there?
Yes, sir. No clarification.
All right. We'll stop the class, madam. I'll stop the class, ma'am.
Okay, sir.
Yeah, ma'am. I'm tired. Yeah.